Multivariable Calculus 14.4, our second day and our second part of differentials. We were saying before, right at the close of the video, that even if you have a function of 3 or even more variables, the basic premise for the differential is actually very similar. If w is your function, dw, the change in your linear approximation, would be your derivative of that function with respect to x times delta x plus the derivative of your function with respect to y times delta y plus, and you keep going. Delta y and dy, of course, are the same. If you have a z variable, you take your derivative of z and multiply by delta z. So let's take a look at our last problem. It says the dimensions of a rectangular box are 75, 60, and 40. So very much what you can see is its length, width, and height. So, you know, just as we had learned in our days of geometry, volume was always length times width times height. So volume is a function of those three variables. And our beginning length would be 75, our beginning width would be 60, and our beginning height would be 40. All of these dimensions, of course, are in centimeters. Each measurement's correct to 0.2, so delta L would be 0.2, delta W would be 0.2, and delta could also be D, DL, DW. They're one and the same. Delta H would be 0.2. So we'd like to get an approximation for the largest possible error that we could have. So we need to take our derivative of volume with respect to L. And when we do that, L just goes away. We'd have W and H. Take our derivative with respect to W, and we just have L and H. Take our derivative with respect to H, and we'll have L and W. And of course, we're going to plug in, we're going to plug in these initial values as we work this out. But what's really happening is dV is going to be the derivative of our volume with respect to L times delta L. Or how about I use cursive the way we were doing before? That might look a little nicer. And then we'll say plus the derivative of volume with respect to W, the width, times delta W. Finally, we'll have our derivative of volume with respect to H, the height, times delta H. So as we're working this out, W and H are really what we'd have here. So it's W naught and H naught times delta L. You know, here it would be L naught and H naught times delta W. This would be L naught, W naught times delta H. And of course, now you just plug all this in. Your beginning W would be 60. Beginning H would be 40. This would be 0.2. L naught would be 75. H naught would be 40, and again a 0.2. Finally, as we conclude this would be 75, 60, and a 0.2. And if you were to work all of this out, you could confirm very quickly that you'd get 1,980 cubic centimeters. I'll allow you to check that on the calculator. That's just some button pushing. But this would be an estimate of the greatest error that we could have.